Right, hello there ladies and gents, welcome to another repair video. Today we're going to be taking a look at this Xbox One X which has been sent in. And this particular console has been sent in because it won't insert discs into the disk drive. Now, while this sounds like a relatively simple and straightforward job, most people would just attempt to change the disk drive. The unfortunate news is the disk drive has already been changed, and as we can see here, what it says, can't insert discs, tried replacement drive. Let's verify the issue first of all, as we always do, and then we'll open it up and we'll see if we can figure out what's going on, see if we can fix it, and hopefully get this console working again. Okay, so I'm just turning it on now, and if we try and get the thing to show up on screen, there we go. Okay, so we've got the Xbox One X logo here. Okay, and I'm going to sync my controller, my very bodged controller. Hey, and I apologise if the audio is a little bit different today. Unfortunately, the microphone that I usually use, the lavalier mic, the clip is broken, so it's a little bit difficult. So right now I'm using my headset with a headset splitter, so I can actually connect it up to the PC. Fingers crossed it's going to be more or less the same quality audio, but I don't know until we actually get to the end of the video, so hopefully it's at least the same quality as what it usually is. Okay, so taking a little while to load into the dashboard here. There we go. Okay, so if we take a look, let's press the disk drive eject button. Okay, so the disk drive eject button is responsive. So I'll get myself a test disk here. This is Call of Duty World War II. And yep, so completely dead, no power at all to the disk drive. Okay, right, let's try and press eject, see if it spits it out. Nothing at all, completely and utterly dead in terms of the disk drive. Okay, so I'm going to take this apart and I'm going to try and figure out what's going on. So just wait for that to shut down and then I can unplug it. Awesome. Okay, so I'm going to take this apart. I'm not going to do that on camera because we've all seen these consoles taken apart before. So yeah, I'll see you on the other side. Okay, so let's take a look first of all and check the state of the connection and things like that. I mean, the cable looks okay. I don't see any bent pins inside the power connector. And I'm going to pop the power supply back in. There we go. Okay, so what I'm going to do then, I'm going to get my multimeter and I'm going to see if I can get some readings from the actual connector by using this end of the cable. So I need to plug this back in and I also need to turn it on. Let's turn it on then. There we go. So that's on. Okay, so I've got my multimeter set into DC mode then. Hopefully you guys can see that. You probably can't with the reflections and things, but never mind. So we don't actually need a screen on to be able to test for voltage and things. Right, so let's try and get some readings. So we got 3.2 volts there on that pin. Nothing on that pin. Does that pin... See, the problem is as well is I haven't got the disk drive eject button hooked up as well, so it's going to be a little bit tricky to do some testing with these. Right, we've got 1 millivolt there. No. Interesting. So I'm getting 3 volts here. Why is that pulsing? Just a loose connection. Right, I think the best option is to probably plug another disk drive in and see if it actually takes a disk in. So I think I'll do that. Right, so I'm going to turn this off. Just going to unplug that there. And I'm just going to basically plug in another disk drive and see basically what happens. Right, okay then ladies and gents, so it's actually the next day. I had to source a Xbox One X disk drive yesterday, so as you can see I've got 2 disk drives here for the Xbox One X. This is the one that I'm going to be using to see if I can verify any issue. So I've got my own cable for this one as well, and I know this disk drive works because I've just tested it in another console. So it's obviously got the daughter board from the other console in it, and the reason for that is because I want to try and eliminate possible reasons that it's not working. So one of the reasons that it could not be working is because of a fault on the disk drive daughter board, and the other reason is a fault on the actual motherboard itself. If it's the motherboard, then we can diagnose the motherboard, and if it's the daughter board, then we can diagnose the daughter board and see if we can figure out what's going on. Right, I'm going to need to temporarily connect up the eject button. Reason being is because I actually know there's a disc in here. There's an Xbox 360 disc in here, so I'm going to have to unplug it for a second, and I'm just going to have to temporarily connect up the disk drive. Let's just connect up that disk drive, or the button rather, and let's plug it back in. And there's nothing happening with that at all. I wonder if that's because there's no SATA drive in there, or no SATA cable in there. That is a possibility. I'm going to turn it off once more and just plug in this SATA cable. First of all, I am actually going to just check the cable and make sure that we've got no issues with the cable, and it doesn't look broken anywhere, but I have come across it before where I've had a broken SATA cable, and that's all that stopped the disk drive from working. So that's why I check the cable. Right, so it's an issue on the motherboard. That eject button isn't working at all, so yeah, it's definitely an issue on the motherboard itself. Now obviously we can't put a disk in there because there's a disk in there. Right, what I need to do first is make sure that I don't get these disk drives mixed up. So let's pop that one out of there, and I'll just plug it back into it. Right, so what I have done then is I have ruled out any possibility that it's anything to do with the cables or the disk drive itself, because I've used my own cables, my own power cable, and a different SATA cable, and I've also used a different disk drive. So it's likely going to be something to do with the motherboard itself then. Right, okay then, so taking a look at the disk drive circuit there, we've got the optical disk drive power connector, which is this white connector just here. So that's where power comes out from the motherboard to the disk drive, and if we take a look just below the actual circuit, we don't really have a lot of components there which could go wrong. I mean, we've got, let me just get my multimeter probes and I'll point to it. So we've got the power connector here, so power comes out here, and from this power connector here we come, or rather before we get to this power connector here, it looks like we come down here. So looking at this, looking at the colour changes on the board, it looks like we've got ground up here, and we've got the whatever volt side, the different voltage rails here. But yeah, it looks like we haven't really got a lot. We've got a little transistor here. We've got a couple of caps which are going to be smoothing out power. We've got a few more capacitors just here. Looks like we've got a MOSFET here. I don't know what the value of that MOSFET is. Or I don't know what MOSFET that actually is. We could probably read the numbers on that. The easiest way that I've found to read these things when we can't read them, because at the moment we can't read anything on here. Now we do have the option to zoom in on the actual, oh there we go. Right, so the number on here is 7403, is that? I've got something on my screen so I can't really see it. 7403, and then we've got 3V7X2S. I'm not sure whether or not that MOSFET is the same as the ones on the Xbox One S, because if it is, then I've got stacks of them in stock, but if not, then, you know what, I don't know. But I don't know the ratings for these. I'm assuming it's not going to be the same, because the ratings on the other ones I think are 30 volt, rated at 30 volts or something, or 30, I don't know, 30 volts I think it is, but Yeah, I'm not really sure. I'll have to obviously do some research on these components here, but that's the part number for that MOSFET. And then we've got just KFD724 on this transistor here. So what I'm doing there is actually wiping the components with isopropyl alcohol, and that just allows me to read it a little bit better. So you can see it comes up a little bit clearer there. But other than that, there's really not a lot that can go wrong on these. First of all, we can pop our multimeter into diode mode, and we can test this. We can test this little MOSFET here. So, I mean, if you've watched any of my other videos, you'll know how easy a MOSFET is to test. If we put the multimeter into diode mode and then put one probe on ground, so we just find a common ground point. In this case, I'm going to just be using one of the ports, the casing to one of the ports. And if we just look on the MOSFET here, we've got 4 traces here, which are all the same. And then we've got 3 traces here, which are the same, but then we've got one on its own just here. And if we pop the probe onto that one, bear with me. Okay, right now we are getting open line. So that MOSFET isn't working by the look of it, or something on this circuit is wrong. That's interesting. Now that little bit of whatever there is just isopropyl alcohol, so that will evaporate, as you can see. It's just isopropyl alcohol from where I've been wiping the MOSFET. Nothing to worry about with that. I don't see any signs of liquid damage. I don't see any signs of any damaged components, but MOSFETs you can't really tell. So we've got a MOSFET here that could go bad. We've got a transistor over the other side that could go bad. Let's pop the multimeter into continuity mode. That's the mode that's going to beep when we complete the circuit. And let's pop one probe on ground. And we have no direct short to ground there. Okay, so let's test these caps over here, shall we? Right, so that trace there is a ground trace. And we get nothing. Right, let's have a look at some of these pins on the connector. Right, so these 3 are ground. These 2 are not. So this is weird, because this MOSFET here is coming up as open line. So the MOSFET's reading open line, but I don't think it should read as open line. Should be getting some sort of diode mode reading there. Let's flip the leads around and see what we get the other side. Right, we get 1.535 on the other side. That seems about roughly normal. But this side, we get nothing. I'll tell you what I'm going to do. I'm going to go into the house. I've got another Xbox taken apart in the house. I'm going to get a diode mode reading on that MOSFET, because that doesn't seem right how it's not giving me a reading on one side. So I'm going to go and test that. And if I get a different reading, then I'll obviously look into that MOSFET, because that's the only thing that I see that seems to be out of place at the moment. So I'll get a reading on that, and I'll try and probe a few other areas on that other board and try and get some known good readings as well. Right, okay, so I just took a look on the other board, and the reading that I'm getting appears to be correct in terms of the MOSFET, but and that's on a known good working board. So basically I've got a console in the house which I've taken apart to take a disk drive out of, and I've just got the readings, and I've also got the readings of the power connector as well. So what I'm going to do is I'm going to plug the power in, so I'm gonna turn it on. It's gonna be difficult. I'm not gonna be able to get this on camera. It's just physically impossible. But I'm gonna try and get some readings in voltage mode because I've just got the readings from the other one on the power connector itself. And I know what voltages I should be getting on certain pins. So if I turn the console on, then let's just null the leads. There we go. Okay, so I'm going to pop one probe on ground, black probe on ground. Now I can get the voltage readings on camera, but I can't show you the pins that I'm connecting to. So looking at the board face on, the top left pin should be 3.3 volts. And yep, they're about 3.3 volts. And then if we look on the bottom row, the third pin from the left should be 3 volts. That's correct. The next pin should be 5. Correct. And the next pin should be 12. And that is incorrect. So we don't have 12 volt coming in. So we've got a missing 12 volt rail. And let's move to that next one. Make sure there's nothing wrong with my leads. Yeah, so we've got 5 volts, but we've got no 12 volt on the pin next to it. So there's a 12 volt rail missing. Why is there a 12 volt rail missing? That is the question, and the problem is I don't know where that 12 volt rail comes from. So I think we're going to have to go back under the microscope and take a look. So the pin I was referring to, if we take a look at the connector here, I'll just try and get them all in shot. There we go. Okay, so the pin I was referring to, we should be getting 3.3 volts on this one, which we are. We should be getting 3.3 volts on this one, which we are. 5 volts on this one, which we are, and 12 volts on this one, which is no 12 volt. So I need to trace this back. I need to figure out where this 12 volt comes from. So 12 volts is supposed to be coming from that pin. So if we follow this back, so we've got the pin here. Okay, and we have continuity across those two pins. So we come to here, and then we come to this MOSFET here. So I'm assuming it comes through this MOSFET then. Okay, so let's plug it back in. I'm assuming it comes through that MOSFET. So let's turn her on. Let's go back into voltage mode. So I'm back in voltage mode now. So I'm going to try and trace this back. This might be difficult because we don't have any schematics for this board. So it's going to be really difficult to find these. Okay, so obviously we don't have 12 volts on that MOSFET. We actually have 0.9. 0.9 volts on that MOSFET, so something's pulling that line down. But we do have 12 volts coming in. Let me see if I can get this on the microscope. Right, so if we take a look here, we can barely see this because I've got the power supply in. I've got one probe on ground. And if we take a look on the pin, we're getting 0.8 volts, 0.9 volts, and well, it's bouncing up and down. It's actually jumping up and down. So we're getting like 0.8 volts around about that on the actual MOSFET. And if we come down to the capacitors, where it goes to next. We're now getting absolutely nothing. But if we come down here to this MOSFET, this side of the MOSFET here, I've got 12 volts on this side of the MOSFET, but then I don't have anything on this pin here. So this is going to be the source. This is going to be the gate, and the other side is going to be the drain where it comes out. I think that's how it works. So we've got 12 volts on the source. Do we have 12 volts on this coil? We do. So on the coil itself, you can see my probe here. We've got 12 volts. So it comes up here. We've got 12 volts at the capacitors. So what I need to do is I need to find one of them MOSFETs. I need to figure out what MOSFET that is, and I need to basically replace that MOSFET. Now the problem is I don't know what that MOSFET is because we don't have any kind of schematics. One thing I'm wondering is whether or not it's the same on an Xbox One X, because I don't have any donor boards available for the Xbox One X. They are very, very difficult to come by. So what I'm going to do then, I'm going to move this out of the way. So what I'm doing is I'm just going to move this out of the way, and I'm going to take a look around that area on the Xbox One S. So I've got a donor board here, and let's take a look around that general area, which is just here. Do we have a similar MOSFET here? And I believe we do. Just here. Right, so what is this MOSFET here then? So let's zoom in on this here. Let's see if this MOSFET matches. 8131743. I think it's probably the same MOSFET. Okay, so I'm going to take this MOSFET off here and I'm going to put it onto the Xbox One X, I think. Okay, so here is the MOSFET that I'm looking at, and I've got to be really careful now because there is a SATA connector right up above it. And what I'm actually going to do, I think, is I'm going to try and protect that SATA connector as best I can. I mean, worst case scenario is I can always replace that SATA connector afterwards. I don't think I'm going to be able to protect it. The only thing I'm going to be able to do, I think, is put a bit of Kapton tape there. So I will put some Kapton tape there, but there's not really a lot that I'm going to be able to do in terms of protecting that SATA connector or the power connector itself. I'll just put a bit of Kapton tape across there just to protect it as best I can. I do use an angled nozzle, so I can kind of get as precise as I can possibly get, but I believe this MOSFET is bad, so that's why I'm going to change it. Okay, that actually just broke off. The MOSFET actually just broke while I was taking it off, so that could potentially be the reason why this is not working. What I'm going to do, rather than risking any more damage to that SATA connector, I mean, it is a little bit melted, it is a little bit browned, but it's not melted or anything, so rather than risking it anymore, what I'm going to do, I think, is I'm going to just use a soldering iron to get it off. So I'm going to swap to a fairly big tip on the soldering iron. So another reason I'm thinking that that MOSFET is bad is purely because it just broke off while I was removing it. Now MOSFET shouldn't do that, it should come off as one piece. So I've got a feeling it's probably bad. I mean, worst case scenario is I can always buy one of those MOSFETs. I'm sure I'll find them somewhere. Or I'll take one off my own Xbox and then use it and then replace it at a later date. I don't play my Xbox anyway, to be honest. So worst case scenario is I can take one from my board and then just replace it at a later time. But for now, let's just get this cleaned up. Okay, so I'm going to add some flux here. And then I'm just going to blast a bit of leaded solder over the top of this MOSFET, or what remains of the MOSFET at least. And there we go, so you can see there that that MOSFET Let's come away from the board. So now I'm just going to wick away some of this excess solder. Okay, there we go. And now that we've wicked away that solder, I'm going to put some more Kapton tape around that connector. But now that we only have leaded solder on there, it's not going to take as long to put a new MOSFET on. So it's going to be a lot easier to get it on without risking much damage to the connector. Because that's the main thing here, is we've got to protect that connector, because if we do damage that connector, then we've got no chance of getting this working. Or at least not without replacing the connector anyway. Now the problem is, when you're working in such a tight area, is sometimes you can't really I'm not going to be able to work with that. Sometimes you just can't avoid using heat around plastic or sensitive components. Okay, so this particular MOSFET, I don't really need to know, there's no markings on the board, but I don't need to know which way it goes, because MOSFETs only go one way anyway. We've got a big pad one side, and then we've got 4 pins on the other. So I don't really need to know which way it goes in order to get it on the board properly. This particular MOSFET I've just taken from an Xbox One S motherboard. Now I don't know if it's exactly the same, but it's probably a compatible part. Right, so let's add a bit more flux here. There we go. So you saw that flowed into place, but I'm going to clean it up using the soldering iron anyway. Because I want to keep heat to a minimum on that connector. And it looks like all of the pins are still intact at least, so that's a good thing. So I'm going to finish cleaning up with the iron. Okay. Right, so let's clean it up using some isopropyl alcohol. So I'm going to use a toothbrush for this, because I want to get in between the connector. And then we can see and make sure that we haven't completely screwed the connector up. Shouldn't be a problem though. I'm just hoping that we're able to use this MOSFET. But just given the fact that the MOSFET was actually broken, or it broke off while I was removing it, it speaks volumes. It really does. So I'm just going to dry this area off. Just a tiny bit of heat for a few seconds, and then I'll just clean it up with a cotton swab as well. Okay, so the black bits around there are just a little bit of plastic from the connector. It's not too bad. Got a little bit of scorching, but nothing major. And the actual connector itself, the pins on the connector itself are actually good, so it's fine. A little bit of scorching, that's to be expected. Not really a lot we can do about that. It's very close to it. As you can see though, if we just tilt it, hopefully I can get a view. Alright, so I'm not going to get a clear view there, but the pins are intact. It's not melted or anything, so not a problem. Right, so let's go back onto the camera then, and we'll just plug it in. Hopefully nothing goes bang. Okay, let's turn it on. And back in voltage mode now then. And I'm going to pop the black probe on ground. And we've got 12 volts at the pin. Look at that, that's beautiful. We now have 12 volts at the pin. I'm hoping that comes across on camera, but we have 12 volts at that pin. That is absolutely awesome. So the 12 volt rail is restored. So I'm going to say that the problem was probably with that connector, that MOSFET. So let's try and get this. I might find it a little bit difficult to get this connector back in now, because like I said, there is a bit of scorching to that connector, but that's just what I like to call collateral damage when you're working on this kind of an area. Now I could change the connector, but if it works, then I'm not going to mess anymore. I can always break away some of the plastic around the connector if I need to. Right, so some of the connector has broken away anyway, but like I said, it's collateral damage. There's nothing you can really do about it. Right, so the reason this connector isn't going in is because the connector is actually broken a little bit. I'm not going to sit here and fret over that if it gets this console working again. So, I mean, obviously, there's no way that we can do this without replacing that MOSFET. So, it's just one of them things. Right, so I'm going to need the oh, something just went pop. I just heard something go pop. That's not good. Has that MOSFET gone again? I'm assuming that MOSFET's just died again. But why? I mean, the console's coming on. The console's on. But why has that just gone pop and turned off? Something wasn't happy, was it? Right, let's I heard something bang. Or not bang, I heard something pop as if something else has just failed. Let's see if we've lost the 12 volt pin. That's pretty annoying, to be honest. Whoops, pressed that a few too many times. Has it stayed on? Yeah, never mind. Right, so that pin. Yeah, we've lost 12 volt again. This time we've also lost 5 volt. Yeah, 1 volt. Okay, I think what I'm going to have to do is take that MOSFET from the other console, but I'm going to need to make sure I can get that MOSFET first. But before I actually go and start pulling components off a good working board, let's go back under the scope. That MOSFET has died again for sure. Okay, so I'm wondering, is it an issue with the disk drive daughter board? And that's what's blowing the MOSFET. So let's remove this. It's not going to take as much to remove this because it's leaded solder. There you go. So you can see that's just come straight off. So I'm going to get another donor board. I'm going to put another MOSFET on. Right, I'll tell you what I'll do. I'll take this MOSFET off another Xbox One. Because they can't be different. They can't be. They're exactly the same circuit. They use the same disk drives. They use the same connectors. The only difference between the Xbox One S and the Xbox One X is the fact that it's 4K. The disk drive is exactly the same. The disk drive is still a Blu-ray player. It's pretty much the same model. That's the same MOSFET, I think. 7403. I think that's the same MOSFET on that one. Pretty sure it is. So what I'm going to do then, I think, is well, I've got to put some fresh solder on here first. But basically, what I can do, if I just turn this on, or if I just put this MOSFET on, and then turn it on and just leave it running for 5 minutes, and then see if it blows that MOSFET again. Because if it doesn't blow it, then obviously there's got to be some sort of an issue with the disk drive itself, right? But I don't know. We'll figure it out, I'm sure. Right, so let's just get rid of some of this excess solder from here. Okay, so yeah, I mean, I'm not really sure why that blew again, but I mean, you never know. It's a donor board. That MOSFET could have been on the way out, but that's very, very doubtful for me to pick a donor board up and have it have the exact same fault. It's very doubtful indeed, because these shouldn't die. Okay, these disk drives shouldn't die. There shouldn't be any reason why we're not getting why these MOSFETs are popping, unless there's an issue with the daughter board itself. I mean, these MOSFETs are generally, as a general rule, these MOSFETs are pretty reliable. So I am wondering what's causing it to blow, and I think it's probably something on the disk drive. But the problem with that is if that daughter board is dead, are we going to be able to fix it? Because it's the daughter board. It's the thing that we can't replace. Okay, so that's cleaned up enough just for testing. Right. So what I'm going to do then, I'm going to pop this console on. So let's go to turn it on. Okay. No pop and bang so far. So let's pop one probe on ground then. Let's see if we're getting a reading on 12 volt pin. We are. So we've got the 12 volt back again. So what I'm going to do, I'm going to leave this turned on for like 3-4 minutes. Whatever, like 5 minutes or so. I'm going to go and pop to get a drink and things like that. I'm going to leave this turned on. I'm going to come back and see if it's popped that MOSFET again, because it took a few seconds to pop it before, but it was only when I put the disk drive in that it popped. So I'm thinking there's probably an issue with the disk drive. Now obviously that's going to be a big problem if there is. Yeah, let's leave it a couple of minutes and see what happens in terms of the disk drive. See whether it pops it or not. Okay then, ladies and gents. So here we are again, and the console is still turned on. It's been about 10 minutes. So let's see if we've got the same. See if we've got the same 12 volt rail. Whoops, slipped a little there. Right, so we've still got the 12 volt rail. So the question is, why did this die? Why did this die? Okay, so what I'm going to do then, I'm going to unplug this. I'm going to plug my own disk drive in, one that I know 100% works. I need a SATA cable actually. I was just thinking to myself, why isn't this turning on? But then, you know, if I haven't got the power supply in, it's not going to turn on, is it? Oh, I'm such a moron. Oh, never mind. Okay. Right, so let's turn it on. and that's just ejected the disk. That's just ejected the disk. It's also taking the disk in. Let me see if I can get you a view on that. So press the eject button. Yes, it's upside down because the console is actually upside down when it's facing this way. That is working. So, I mean, these MOSFETs, I mean, it doesn't matter if I keep blowing them. It doesn't really make a difference. Right, I'm going to pop the other one in then now. Actually, let's open it up and just see if we can see anything on the disk drive first. Let's not plug it straight in. Let's open it up. Let's see if we can see anything on the disk drive, and let's see if we can figure out what's going on. So I'm gonna have to go and get my screwdriver because that's in the house. Great. Okay, so I'm gonna take this apart then, this disk drive, and I'm gonna see if I can figure out what's going on with the daughter board. Right, I can't see anything obvious on that daughter board at all. So, what I think I'm going to do then is I'm going to plug it in and see if it pops. That's probably the best thing to do. I'm going to have to change that connector as well, by the way. Ah, that's just popped again. There's something wrong with this daughter board. Okay, right, let's get all of this out of the way then. Might be a case of trying to do a daughter board swap on this, I think. I can't see anything obvious. I'm going to go under the microscope. Okay, so here we have the... Right, so we have power coming in here. So power comes in here. And just here we have the disk drive controller. So this is a custom ARM chip by Microsoft, and this is the chip in particular that's married to the motherboard. So if I just soak that and then dry her off, you can see it's a Microsoft ARM chip. So this is a custom controller by Microsoft. That's what's married to the board. And then down here we've got the connectors. This is the disk drive motor controller. So this is what controls the motors on the daughter board, on the disk drive. You know, the one that opens and that ejects and accepts a disk. So that's what controls that. Now the problem is, to be honest, I don't really know where to start. Right, okay, maybe I do. Because these caps here look a little bit burnt out, don't they? Well, they don't look burnt out, but they look discoloured. Same as these ones here. So there's a few different things that look a bit discoloured and things here. So what I'm thinking is rather than sitting there and trying to diagnose this board, should I just do a daughter board swap and hope that it's not the chip that's gone? I mean, nothing looks out of place up here. I mean, I can test for shorts and things around here, I suppose. So if I go into continuity mode, and I believe that should be a ground. Yep, so that's ground there. Okay, so let's actually let's go on this one here. Right, so what I'm going to do then is I'm just going to basically, now I don't know the pinout to this chip because like I said it's a custom chip. I don't have a clue what the pinout's going to be to this chip. So what I'm going to do instead is I'm just going to run across all of these pins. I'm going to keep one probe on ground. And then I'm going to run across all of these pins on this ARM chip. And just see if I can find any shorts to ground. And then if I find some that are shorted to ground, I can just take a look at the trace. And follow the trace to see if it's meant to be shorted to ground. Okay, so just there. Let's just focus. That is meant to be a ground. Okay, so that there, if we take a look, if we follow this trace here, and it goes to this connection here, that's going to be a ground. That's going to be meant to be there. So I'm going to say that there's probably something wrong down here, where these capacitors and things are a little bit discoloured. But the problem is, tracing that back is going to take much longer than it would to just swap the board. So to swap the board, we're going to need to swap this chip over to a new board. And that's actually relatively simple to do. The solder on these are not that hard. It's not that hard to remove. So what I'm going to do is I'm going to remove this chip. I'm going to take a daughter board from an Xbox One S. And I'm going to put the daughter board from the Xbox One S onto this. I'm going to put the chip onto a daughter board from an Xbox One S. And then hope that it doesn't blow the MOSFET again when I replace it again. Kind of mangled that up a little bit, but I don't really care because I'm not going to be reusing this disk drive, this daughter board. So I don't really care that those caps come off and things. So what I'm going to do now, I'm going to find a donor board that I can use, a donor daughter board that I can use, and I'll get that chip replaced, and or get that chip swapped over and hope for the best. Okay, so I've got myself a donor board here, and this board in particular actually already has the chip taken off it, so it should be a little bit quicker to get this back on. And it doesn't look like there's any missing components around there, so that's great. Right, so let's just get this in the proper orientation, which is going to be face on, like that. I'm just going to roughly line it up. So that's roughly in the right place. I'm just going to put some heat on it just to tack it down into place. Whoops. Okay, that's tacked into place now. Doesn't have to be perfect, like I said, because I'm going to straighten it up in a second. I do need to add some flux first. Okay. Okay, so I'm going to turn my airflow up now to back to 60%. Actually, let's go for 70%. Okay, good. So that appears to be in position. So what I'm going to do then is I'm going to get the soldering iron. I'm going to swap my tip back to a fairly small knife tip. And while I'm waiting for that to heat up, I'm going to add yet more flux. And let's just go across these pins. So I'm going to zoom in now because I need to get fairly precise with this. Uh, Zoom out enough so you can see. That looks fairly straight, doesn't it? Okay. Let's do the other side. So I'm going to use my right hand now, which isn't easy for me. There we go. Beautiful. Beautiful looking joints there. Okay, let's clean that area up and then I'll take a look on an angle and make sure that it's actually centered. Always want to double check this first because we do not want to cause damage to this chip by having a pin somewhere where it shouldn't. For example, having power going into somewhere where it should be data. That would be a catastrophe. So I will double check and make sure that all four sides are soldered correctly. It doesn't matter when it's something like a HDMI retimer chip or something. You know, if we get a pin in the wrong place where it's slightly off center and we end up blowing the chip, what's the big deal? We're just going to replace the chip again. But with this case, this has to be absolutely perfect because we only get one shot at this if we turn it on. If this is wrong, we are going to end up blowing this chip and it is going to end up causing this console to never ever ever be repairable by anyone. So we do not want to damage this chip. There we go, so that's dried off nicely and it does look like they're all dead center. We can see that the pads appear to join up properly, but we're going to check on an angle anyway. So if I just lift it up onto an angle and then we can basically just adjust the microscope so as it works for us. And there we go, look, that looks absolutely perfect all the way across. Perfectly uniform joints. Let's take a look on the other side, so let's flip it around. Perfect. That looks absolutely beautiful, doesn't it? How about this side? Yep. Perfect. And how about the top? Beautiful. Okay, right. So if we go back to the normal cam now then. Now obviously there are some burn marks on this daughter board here, but that's just where I removed the old chip. I've had this daughter board for quite some time. I've got quite a few. It's always good to have these as donors because this is essentially a daughter board swap. Shoot, I've took the motor controller off this one. I didn't even notice that. Now the problem is if it's a motor controller what's gone on the other one, then I'm kind of stuffed, aren't I? Right, we can take the motor controller off this one, I think. As far as I know, the motor controllers are the same on all of them. Let's just have a look under the scope and see. So this motor controller, it says, is it 641 or something? I don't know. 641, something like that. And the motor controller on the customer's board, oh, it says 75T, damn it. Shoot. I don't know if they're the same. I think they're the same. Right, I think the best thing to do then is probably. Actually, you know what? This is yeah, this is the same board. So yeah, I'm gonna it's the same board, but it's a different colour. So I'm gonna swap the motor controller over from this one. I don't really want to put any more heat on that disk drive, on that ARM chip, to be honest. I don't know what kind of heat that can take. Right, so I mean the only way to find out is to kill one of them, and I don't really want to do that, so it's not an option. So what I'll do, I'll take the motor controller off this one. Okay, so that's that. Right, so let's take the soldering iron then. Let's add some flux. So let's get this motor controller in position then. So let's drop the airflow down to 40%. Let's change the airflow back to 70. I'm actually one pin out on this. Okay, so I'm going to take the soldering iron now then, and I'm just going to solder all of these by hand properly. Just make sure we've got some nice joints on each pin. Okay, so I'm going to clean off the excess to that in a minute. Not really concerned about it right now. So as I'm going backwards and forwards with these legs, it's actually sticking a little bit of solder each time onto the iron and getting rid of the excess for me. I could use wick. There's different ways that you can do this. I'm going to use wick for the last little bit, I think. Right, so let's clean this up then. I did notice that I've got a capacitor off here. I think that's meant to be there, I'm assuming. Ah, no, I can see where it's come from. Right, so there's a capacitor just here which has come from here. So I'm going to get the heat gun. Let's pop that capacitor back into position. There we go. Okay, let's get a bit more flux and we'll just finish cleaning these legs up. We do have a little bit of a bridge there. So hopefully that's straightened everything out now. But let's double check. Clean up that chip. And now I'm going to get in real close to this chip. I'm just going to check every pin. And we might have a bridge on these pins here, I believe. Yep, so we've got a bridge there. Okay. So we've got a bridge there, and we've got a bridge on the top as well. Just there. And that's why we're getting very close on these, because it allows us to see the bridges. There we go. A lot of excess solder hiding behind here. I'll just drag that off. Well, out of visibility, out of view. Dragged it onto the end, and there's a lot of excess solder. Just going to keep tapping away with the soldering iron, and it should clear up eventually. Actually, let's just use some wick. So those bridges should be all cleared now. And let's dry up. And one final time, I'm going to get him very, very close. Okay, that looks good. So back to the main camera then. Let's pop the daughterboard inside the disk drive. Let's get this big ribbon in. And hopefully it doesn't pop another MOSFET when we do put it back on. So I need to replace the MOSFET once more because it's popped it again, hasn't it? So I'm going to have to replace another MOSFET before we go any further, which is annoying, but it is what it is, I suppose. Okay, so let's what are we doing now? Right, we're going to put this back on. Screw it all back down. So the reason I've swapped the daughterboard instead of trying to find the fault is because it just takes too long, and it could have various faults, whereas if I just swap the daughterboard for a new one and change the daughterboard's chip, then, you know, it's basically solving itself. Sometimes it's just easier rather than sitting there trying to fault find on something that could well be a rabbit hole. Whereas now, if I let's say for example now I basically I plug this back in and it still blows, then I know it's a problem with the ARM chip. And for some reason that's not screwing in. I don't know why. Are they the wrong screw? I think they are. Yeah, they are. They're the screws off a PS4 disk drive. So like I said earlier, I'm a moron. Never mind. Yeah, if we plug this in now, if we fix this, replace this MOSFET now, and then plug this back in and it blows again, then I know it's an issue with that ARM chip, and then I'm going to obviously just give up and say no, it can't be fixed. That's it, it's dead. But if it's a case of it doesn't blow now, then we know it was something on the daughterboard and not the ARM chip. Right, so let's get the console back then, shall we? So I need to change this MOSFET once again. So I'm just going to unplug this. I'm going to remove these cables from the disk drive. And I'm going to get that MOSFET off. So let's go under the scope then, so I can actually see what I'm doing. There we go. Alright, so that's tacked in place, so I can get some flux on there now. Okay, that's good enough. We'll clean it up, but that's on there. That's the main thing. Okay, so I'm just going to get some isopropyl alcohol and just clean this board. Definitely going to need to change that connector. It's seen better days, hasn't it? All of the removing and replacing those capacitors, those MOSFETs has caused that. There's really nothing I can do about it. I can desolder one from another board. It's not really a big issue, to be honest, to have to replace it. Okay, ladies and gents, apologies for the little jump cut there. So, too many disturbances today, but I'm not sure where I actually got to in terms of this thing. I think I've just replaced that MOSFET, haven't I? So, I'm going to plug a disk drive in, and we'll see if it pops again, shall we? Right, so let's plug this in. Okay, so let's pop in some power. That hasn't popped yet. We have disk feed. Right, let's press that button. There we go. Right, so let's hope for the best in that that's fixed. So what I need to do now is I need to plug this in to a HDMI lead. So let's get my HDMI. And I'm going to try and take a connector from a donor board without damaging it in a minute. So let's pop that in there. And I'm going to switch over to my capture card now. Okay, so the console appears to be working. Oh shoot, I've just turned it off. I meant to press the eject button. I'm such a noob. Right, so what disc do we have in here then? Okay, that's just come straight back on, but never mind. Right, so we have Call of Duty World War II. Let's pop that in. Right, we've got a disc icon. Now, we do have a disc loaded symbol in the top, on the right hand side, as you can see from the screen. However, there's no image for the there's no image showing up for the disc. But that being said, I've come across this before where I repaired an Xbox One X and we didn't get a disc loading image until we a disc icon until we connected to the internet and updated. So I keep forgetting this console's bloody backwards. So yeah, I mean, I'm not really concerned about that yet. I'm going to connect to the internet and then I'm going to reboot. Call of Duty World War II. So let's go to my apps and games here, and then see all, and then manage the queue. Right, it's not showing up. Okay, so let's go into the settings then, and let's connect up to the internet, and then hopefully, what output do we have? We have 4K output. Excellent. Set up wireless. I'm going to connect to my Wi-Fi. Probably get asked to do an update. There you go. If you know where I live, you get free internet. You might not pick it up from your house though. There we go. Okay, so we are connected to the interwebs. It's probably going to ask us to do an update now. That's probably why it froze on me. Yeah, okay, 567 meg. So I'm going to have to update this. So I'm going to update this, and then I'll be back. Right, okay then, ladies and gents. So the update is almost finished, and it's gone past 58%, which is a good news because that means it's recognising that the disk drive is there. So hopefully this is going to work, and hopefully the disk drive is now fully working. And then all that's left to do, once we confirm that the disk drive works, is replace that connector, which I've already taken one off of a donor board. So the connector is exactly the same as a Xbox One S, and I've taken that from an Xbox One S donor board. So all that's left to do after we've confirmed that the disk drive works is to replace that connector, put a nice new connector on it so as it's not broken anymore, and yeah, then we'll be done, and we can hopefully get this up and running properly. So one little thing I like to do, if I do melt a connector, wherever possible, I would replace it. And it's always best to replace it for the sake of the customer, because if they ever have to take that console apart again, chances are they're going to completely break the connector and it's going to be unusable, and then it's going to be back here under a warranty job. So always best to change that connector as soon as possible, rather than leaving it as it is. Even though it works, it's just not worth leaving it when it's not hard to replace it. I can replace it just using standard heat from a heat gun. And there we go. So the disk drive has updated. The console has updated successfully, which is excellent news. And this disk is installing, which means it's reading the drive, which is great news. So let's take a look at Call of Duty World War II. Let's go to Manage Game. Let's see when it's going to be ready to start. Okay, so it's nearly ready to start, so we might as well leave it and just see if we can actually load up the game. For some reason that's queued. Is it trying to install something else? I don't know. Let's go install now. Right, so drive is spinning up. So it looks like we're around about 8% off being ready to start. We don't need to see it fully install. We just need to see it actually load up the game instead of throwing out an error saying, you know, could not read disk or something. Because the thing is if the disk drive daughterboard, the disk drive daughterboard could be working to a certain extent, but then not be able to authorise playback of the disk. The way that the daughterboards actually work is you can put any daughterboard in a console and it will work as long as the software is already pre-installed, or as long as the operating system is pre-installed. But when you pop in a disk, it will read that disk, but then when you try and load it, it will say that it can't load because it's the wrong disk drive. Whereas the disk drive could be working to a certain point, but then still not be able to load the actual game. So we don't know that until we actually see the game load and actually see the game work. So I'm going to let this run through. I'm going to let it run to whatever percent it needs to go to in order to actually be able to start the game, and then I will obviously try and load it. And as long as I can see that the game loads up and the logo loads up, you know, that splash screen that you get when you load a game, as long as I can see that the splash screen loads up and that the disk drive is actually recognising as a valid disk drive, then I'll go ahead and get the console taken apart, replace the connector, and then call this job done. This has actually had about 2.5-3 hours off me now in total. I did a bit of work last night, and I've done work this morning. It's just yeah, it's one of them things with these disk drives. It could be absolutely anything. And when you've got to replace a MOSFET or when you've got to replace a MOSFET several times before realising that it's actually the daughterboard that's causing it to blow, it just takes longer. But the problem is I can't bill the customer for 3 hours of work because that would come to more than the value of the console. Now, unfortunately for me, this is the first time I've ever had that MOSFET blow, so I've had to diagnose it as a true diagnostic instead of thinking to myself, right, this is what's wrong, this is what the symptoms are, this is what's wrong. Because a lot of repairs are pattern recognition, and you know, when you know the issue, you can get them done in a timely manner. But when you don't know the issue, then you can't. But in future, I'll know where to look first. I'll know to look for that MOSFET first, and I'll know that by checking that MOSFET, I can determine what's wrong. So in the long run, it is more valuable than charging the customer for 3 hours of work. And you know, in the long run, it will benefit me. So we bill the customer a normal amount on what it would cost us if we knew what the issue was, and then in future we know the issue and we know how to fix it. So we've learned something today, for sure. We've definitely learned something today, which is great, because you know, we can't know everything when it comes to consoles, or when it comes to any kind of electronic, really. I mean, I know I specifically really work on consoles. However, the fact of the matter is, you know, we can't know everything, and there's always going to be something new pop up that we haven't come across in the past. I kind of like this guy. He plays all of the classic games by the look of it. But yeah, it's just one of them things. We we have to learn as we go, and we're going to have another learning process when the new Xbox comes out in a month or two, or a month or so. I think it's just over a month away now, about 5 weeks. So yeah, we just learn as we go, and it is what it is. Right, why is that installation stopped again? Stop being stupid. Check your disk. Okay, let's. I mean, the disk is fairly dirty, to be honest. Right, so let's eject the disk. This disk is pretty dirty, so yeah, it's pretty beat up and scratched, to be honest. I'm going to say this probably works. However, I do want to at least get to, like, 13% or whatever it is that it needs to be able to run, just so I can at least see that splash screen and not see an error. Check your disk. Yeah, lovely. I don't think I've got a game that I can use that's going to install really quickly, unfortunately for me. And again, this is another thing that takes time as well. This kind of work, like installing a game just to be able to see it working, is pretty daunting. And I don't think I've got a game that's going to be. I don't think I've got a game that this customer's going to have, to be honest. Games. Yeah, see, there's nothing installed apparently. Most of these games that this customer's using is on Game Pass, which is rather annoying. He hasn't even got Call of Duty Black Ops 4. Right, let's manage queue. Might be a little bit difficult to get up to 13%. Installation stopped. I don't think it's gonna. I think the game's probably too damaged. So I'm probably gonna have to find another game, unfortunately, and do this all over again, which is rather annoying. Right, I'm gonna go and find a smaller game, something that I'm gonna be able to install quickly, I think. Okay, so I've got Mega Drive Classics, which shouldn't be too big of a game, to be honest. I don't know exactly what size it is, but let's try it anyway, shall we? Because I need to at least confirm that this is working. I mean, either way, I'm going to be changing that connector, but I don't want to work on another issue before I fix the issue at hand. So the main issue is the fact that we need to make sure that we've got a disk loading. Getting your game ready. Yes! Yes! It's working! Right, okay, let's just... Right, that was obviously a software glitch then, I hope. I mean, knock on wood, but hopefully that was just a software glitch. Come on, get past that splash screen. There's the Sega logo. I think this is working. Yeah, that's amazing. Right, let's turn off the console. So, let's get this connector removed. So what I'm going to do then to remove the connector is, the connector's this side, so it's just here. So what I'm going to do is I'm going to flip the board around, and I'm going to replace the solder that's on this connector with leaded solder. So while I'm waiting for my soldering iron to warm up, I'm going to replace the solder that's there with leaded solder, and then I'm just going to use the heat gun and heat it up until the connector drops out. So I've got my heat set to 480, airflow 70%. Okay, so let's try and get the replacement connector in then. There we go. So that's in. So now let's add a bit more flux. And then we're just going to solder it in. There we go. That, my friends, is soldered in. Took a little bit of work to get that connector in. Doesn't usually take that long. This one was being a bit of a pain. But it is what it is. Sometimes it can't be helped. Okay, that will do nicely. So let's just make sure that the disk drive actually connects in now, the power connector. Just make sure it goes all the way in. And it does, beautiful. Nice and secure. Awesome. Okay, so final thing I'm going to do then is I'm going to clean the APU, put some fresh thermal paste on, because there's no point in having the console open like it is now and not replace the thermal paste, because it's going to help to keep the console cool, it's going to stop the customer needing to open it, and it's going to prevent any further risk to the console. So if we open it up now and we give it a service, then it prevents any damage in the future. Okay, ladies and gentlemen, we are done. Thank goodness for that. Right, let's give it a final test before we consider this done. I'm going to say it's going to work now. It should be fine. But we do always need to test them after we've put it back together, just in case something happened that we wasn't aware of. So I always tend to test them afterwards, as you'll know if you are a regular watcher of the channel. So we should be getting the Xbox logo coming up very soon. Come on, load up the logo. There we go. Okay, so the logo's loading up. And that took in a disc absolutely smooth as anything. Let's try and eject it. Now I'm hoping you can see that. Beautiful. Right then, okay, so Mega Drive Classics. Popping that in. There we go. Excellent. So that, ladies and gents, is one working console. Right, okay, so time for my favourite part of the video then, and that is going to be the summary. So this console was sent to the company that sent me these consoles because it had no power to the disk drive. The company tried a new disk drive, didn't work, so they sent it to me, and upon further inspection we've determined that we had no power at all to the disk drive, and that it was not the disk drive at fault, it was the motherboard. However, we figured out that the cause of no power to the disk drive was down to the MOSFET, and the MOSFET was controlling the 12 volt line. We replaced that. We got power for a brief second and it popped again, so we replaced it again but tried a different disk drive and it didn't pop, so we determined that there was also an issue with the disk drive. Judging by the state of the disk drive itself, you know, the actual capacitors and things around the drive controller, it turns out that this daughter board was absolutely knackered. So I'm not sure what it was that was causing the daughter board to fail and causing it to blow that MOSFET. However, there was some sort of a serious current draw going through that MOSFET for it to blow pretty much instantaneously as soon as we turned the console on. So by taking the Microsoft custom ARM chip, so the actual chip that's married to the motherboard, by taking that off the daughter board and putting it onto a new daughter board, one that we know works, we're able to restore the disk drive and this console can work once again. Right, so that's going to be for this video. Thanks very much for watching. I hope you enjoyed the content. Let me know what you think down in the comment section down below. And if you do want to see more trying to fix videos where I'll try and fix mainly consoles but sometimes other things too, be sure to hit the subscribe button and turn on the bell notifications so that you're notified every time that I upload. I am trying really hard to get to 5,000 subs by the end of the year, so if you could subscribe it would really help out the channel a lot. But that's going to be for this video. Thanks very much for watching, and until next time, see you later. Bye for now.